Alright, so this is example 2. We've already gotten the answer to example 2 in terms of symbolically what the answer would be, and now what I want to do is actually plug in the numbers that we have to calculate this time, just to show how we need to make sure that we keep track of all of the units correctly so that we can get the answer in the correct units. Alright, so let's assume that I want to calculate this time in seconds. First, I'm going to just to make this a little bit simpler, let me just first calculate what the time squared is. And if I want the time in seconds, then I need to calculate the time squared in seconds squared. So the time squared is d, mass of the electron, divided by the elementary charge, and the magnitude of the electric field. Alright, so I've got numbers for all of these. I've got 1 centimeter, 9.1 times 10 to the negative 31 kilograms, divided by 1.602 times 10 to the negative 19 coulombs, and 100 newtons per coulomb. So the thing that will cause trouble here is the fact that this newton has a length dimension in it, and it is not the centimeter. So if I divide a centimeter by a newton, I'm not going to get something that is in the base SI units, right? So what I need to do is unit convert this answer to seconds squared. So the first thing that I'll do is let me just collect all the numbers in the numerator and the denominator and just calculate what that's going to be first, and then look at the units. So I would write this down as this is the numerator and denominator, the numerical values that are in the numerator and the denominator, and then the units would be over here. Now if I look at the units in the denominator, I've got a coulomb down here and a coulomb here. I'm going to go ahead and cancel those. So what I'm left with is centimeters, kilogram per newton. Alright, so let me just calculate what the numerical portion is going to be and write that down. 5.68 times 10 to the negative 14, and then look at my units. So centimeters, kilogram per newton. So I want to unit convert this to seconds squared. And to do that, I'm going to need to know that 1 newton is 1 kilogram meter per second squared. So I can use this to unit convert the newtons into the SI base units and see what I'm left with. 1 newton, 1 kilogram meter per second squared. So I've got that. I've got newtons in the numerator and denominator, so those will cancel. Notice I've also got kilograms in the numerator and denominator, so those will cancel. I've got centimeters and meters, so those are not going to cancel. I'm going to have to convert one to the other. And it actually doesn't matter which one I convert, but I do need to convert one to the other before I can cancel those. And then I've got seconds in the denominator of the denominator, so that is actually going to go up into the numerator. So I've got centimeters over meters, and then I've got seconds squared. So let me just convert centimeters to meters. There's 100 centimeters and 1 meter. Cancel the centimeters, cancel the meters. I'm left with seconds squared. So this is going to be 5.68 times 10 to the negative 14 multiplied by 100. So that's going to change the times 10 to the power. So if I multiply times 10 to the negative 14 by 100, I get times 10 to the negative 12, and that is seconds squared, which means that the time, which is the square root of that, it's not a very good square root sign, is going to be, hold on, I've made a mistake here. This is times 10 to the negative 14 divided by 100. That's gonna make the exponent more negative. So this should not be times 10 to the negative 12. It should be times 10 to the negative 16. So this is going to be times 10 to the negative 16. And then when I take the square root of that, I'm going to get 2.38 times 10 to the negative 8, and then that is seconds. Right, so I take the square root of seconds squared, I get seconds. Alright, and that's it. So that's a pretty short time. So let's say that I was asked to give my answer in nanoseconds, right? So I've got the answer in seconds. Now how do I convert that to nanoseconds? Well, it's pretty much the same procedure as before. I'm going to take my answer and I'm going to say that 1 second is 1 times 10 to the 9 nanoseconds. So my seconds will cancel. And I just get 23.8 nanoseconds. So 23.8 nanoseconds is how long that would take.